So in our first review video, we were reviewing all the things that we know how to solve, and in this review video, we're going to review all the things that we know how to graph. So let's start with graphing using a slope and a y-intercept. In order to find a slope and a y-intercept when we've got an equation, the first step that's really important is to get y by itself. So here I would start by subtracting the 2x on both sides, and I would get 4y equals negative 2x plus 8. Then I would divide everything by 4, and I would get y equals negative 1/2 x plus 2. Now in this equation, the slope, which we usually call m, would be negative 1/2, and the y-intercept, which we usually call b, would be 2. The b tells me where to begin, and the m tells me how to move. So I would begin at the positive 2, and I would go down 1 right 2, down 1 right 2, down 1 right 2, up 1 left 2, up 1 left 2, up 1 left 2. Then I would just connect the dots. Now, what if the problem said use the x-intercept and the y-intercept to make the graph? You'll notice that this is different than the slope and the y-intercept. So here we said we use the cover it up method. To figure out the x-intercept and the y-intercept, we just cover up the other variable. So to figure out the x-intercept, I cover up the 3y. Now the equation that I can still see would say 2x equals 6. So to solve that in my head, I would just divide by 2, and I would get 3, 0. Now the y-intercept, if I cover up the 2x, I would divide by 3 to get the y by itself, and I would get 0, 2. So if I graph those two separate points, 3, 0, 0, 2, and then I would draw the line. You'll notice that in this problem, the benefit of using the cover it up method is that we don't have to rearrange the equation first. We can sort of just start with what we've got. Now if we've got point-slope form, that's going to be a little bit different. You'll notice that this time the equation looks very different. In order to graph this one, I'm going to need to figure out the point and the slope that were originally in the problem. So to figure out the point, I know I'm going to need an x and a y. And the point, the values are always the opposite numbers of what you see. So by the letter x, I see a positive 4, which means the x would really be a negative 4. By the letter y, I see a minus 2, which means the y would really be a positive 2. Now, the slope would just be the 1/2. I'm going to start at negative 4, 2. I'm going to go up 1 over 2, up 1 over 2, up 1 over 2, or down 1 left 2, and I'm going to connect the dots. Last but not least, we've learned how to graph vertical and horizontal lines. We said the magic word for these kinds of graphs was vuxhoy. So if I want to graph the vertical line, x equals 2, I know that because the equation uses the letter x, it must be vertical, and it must be on the number 2. If I want to graph the equation y equals 4, I know because the equation uses the letter y, it must be a horizontal line, and it would be on the number 4. Now you're noticing I'm using two different colors here because I'm graphing two different lines on the same graph. I want to remember which one went with which equation. Last but not least, we've learned how to graph linear inequalities. Now an inequality is different than an equation because instead of an equal sign, we've got either a greater than or a less than. So the first step here is again going to be to get y by itself. I'm going to subtract 2x on both sides, and I get negative y is greater than negative 2x plus 3. Then I'm going to divide everything by negative 1. So y, and now I'm going to flip the inequality, because it's a negative number that I'm dividing by, is less than 2x minus 3. We're going to start at the negative 3, go up 2 over 1, up 2 over 1, up 2 over 1. Now we're going to decide between solid and dotted. I know that this line is going to be dotted because there's no equal to. So when I draw my line, I'm going to make sure to leave spaces and gaps in the line. And because there's a less than, I know I'm going to shade below the line, which would be this part of the graph right here. These are pretty complex, so let's go ahead and try one more of these just to make sure we've gone over all the different types of graphs we might see. So again, I'm going to get the y by itself. I'm going to subtract the 2x on both sides, and I'm going to get negative y is less than or equal to negative 2x plus 3. I'm going to divide everything by negative 1. Now, because I divided by a negative, I'm going to change this to a greater than or equal to. That's that flip-flop rule. This graph is going to start on the negative 3 and go up 2 over 1. Now, you'll notice the basic setup of the inequality kind of looks the same as this one. There's a y, there's a 2x, there's a minus 3, but the graphs are going to look very different. Instead of using a dotted line, this time I'm going to use the solid line because this time there is an equal to symbol. So already these graphs are looking very different, even though the numbers in the problems are looking the same. Also, because there's a greater than, I'm going to shade above. So instead of shading below, I'm going to shade this part of the graph, which is above the line. And you'll notice these graphs end up being very different in the end because of the inequality specifically. All right, I hope this helped you see sort of the big picture that there's a lot we have in common between graphing lines and graphing inequalities. There's a lot of different options for how to make a graph depending on the way the equation is set up. And I hope this helped you feel more prepared for your semester 1 exam. Tomorrow we're going to be reviewing how to write equations, which we've done quite a few different types. So I'll see you then.